On paper, the Brewster F-2A Buffalo was once praised as one of the most modern U.S. naval fighters of the late 1930s. It featured a monoplane design, an enclosed cockpit, and retractable landing gear, advanced characteristics compared to the older biplanes it was meant to replace. The problem was simple: warfare evolved faster than engineers had anticipated. When World War II erupted in the Pacific, the Buffalo found itself facing the Mitsubishi A6M0, lighter, more maneuverable, and with superior range. As upgrades added armor and extra fuel, the Buffalo became heavier, significantly reducing its climb rate and turning performance. During the Battle of Midway in 1942, U.S. Marine squadrons flying the Buffalo suffered devastating losses, nearly wiped out in a short span of combat. Ironically, Finland used the Buffalo with considerable success against the Soviet Union, but different conditions, tactics, and opponents made all the difference. In American hands in the Pacific, it became a painful lesson. The Buffalo was not useless because it was completely flawed. It was useless because it arrived at the wrong moment. The battlefield does not care about promises, it only recognizes those who survive. The Bell P-39 Airacobra was one of the most unconventional aircraft designs of World War II. Its engine was mounted behind the cockpit instead of in the nose, allowing the front section to house a powerful 37mm cannon firing directly through the propeller hub. In theory, this gave the aircraft devastating firepower, capable of bringing down bombers with just a few accurate hits. On paper, it was a daring technological leap. The problem stemmed from the decision to remove the turbo supercharger to cut costs and simplify production. Without it, the P-39 lost much of its performance at high altitude, the primary arena of air combat in Europe. At those heights, it was outclassed by German fighters with superior climb rates and engine power. In contrast, the Soviet Union deployed the P-39 at low altitudes, where most Eastern Front combat took place close to the ground. In that environment, its heavy armament and sturdy construction proved highly effective. The P-39 was not entirely useless, but it demonstrated a crucial lesson: an aircraft can excel under one set of conditions, and fail completely under another. When the U.S. Navy sought a replacement for the A-4 Skyhawk that was less expensive yet capable of delivering more precise bomb loads, the LTV A-7 Corsair II emerged as a cost-effective but capable solution. It featured an advanced targeting system for its time, could carry a substantial bomb load, and was relatively fuel efficient, qualities that made it attractive on paper. However, early versions revealed significant shortcomings. The underpowered engine limited acceleration and made it difficult to disengage when threatened. Its subsonic speed left it vulnerable in heavily defended environments like Vietnam. Defensive systems and early warning capabilities were also limited, forcing pilots to rely heavily on escort fighters for protection. Later upgrades improved the aircraft considerably, and it went on to serve effectively for many years. But its early operational experience highlighted a harsh reality of modern warfare. Cost savings cannot be the top priority. An attack aircraft must do more than deliver its payload. It must have the performance and survivability to make it back home. The Convair F-102 Delta Dagger was conceived at the height of the Cold War with a single mission: scramble quickly, climb rapidly, and destroy incoming Soviet bombers before they could drop nuclear weapons on American soil. In theory, it was meant to be the steel shield of North American skies. Yet the initial version proved deeply disappointing. It could not reliably achieve supersonic speed as required by its design goals. Serious aerodynamic flaws created excessive drag as the aircraft approached Mach 1. The result was ironic: a jet interceptor that simply was not fast enough to intercept. The U.S. Air Force was forced to redesign much of the fuselage using the area rule principle, narrowing the midsection to reduce transonic drag and shockwave resistance. Only after these major modifications did the F-102 finally meet performance expectations. It was the price of rushed development driven by political pressure and nuclear fear. The F-102 eventually became operationally viable, but fixing those early mistakes cost millions of dollars and several valuable years. The Mikoyan-Gurevich MiG-23 was developed by the Soviet Union to replace the MiG-21, a compact and agile fighter that nonetheless had limitations in radar capability and operational range. With its variable sweep-wing design, the MiG-23 promised to combine high speed when the wings were swept back with improved maneuverability when extended. On paper, it represented a major technological leap forward. Reality, however, proved far more complicated. The swing-wing mechanism added structural weight and increased maintenance complexity. Its powerful engine delivered impressive speed but consumed large amounts of fuel. Early radar systems were unreliable, and its avionics did not provide a decisive edge over contemporary Western fighters. In close-range dogfights, the MiG-23 was often less agile than the very MiG-21 it was meant to replace. Later variants introduced improvements and performed more reliably. But the aircraft's early reputation had already suffered. The MiG-23 illustrated a paradox of military aviation. Greater complexity does not automatically translate into greater effectiveness. Advanced technology only provides an advantage when it is truly dependable in the hands of the pilot. The Blackburn Rock emerged in the late 1930s, when the Royal Navy believed that a fighter equipped with a rear-mounted rotating turret would provide a defensive advantage for protecting naval formations. The Rock carried a 4-machine-gun turret mounted behind the cockpit, but ironically, it had no forward-firing guns at all. According to tactical thinking at the time, the rear gunner would rotate the turret to engage enemy aircraft from multiple angles. In theory, this offered flexible defensive firepower. In practice, however, World War II air combat proved far more unforgiving. Dogfights demanded speed, agility, and concentrated forward firepower for direct attacks. The Rock was heavy, slow, and far less maneuverable due to the bulky turret system it had to carry. As a result, it was almost incapable of competing with German fighters. The Rock was quickly withdrawn from frontline fighter duties and reassigned to secondary roles. It was a defensive concept introduced into an era where the skies increasingly belonged to those who took the initiative and attacked first. When it officially entered service in the late 1930s, the Douglas TBD Devastator was considered a major advancement for the U.S. Navy. It was one of the first torpedo bombers with folding wings for carrier operations. An enclosed cockpit, and an all-metal construction, features that were highly modern for its time. However, World War II erupted amid rapid technological acceleration. By the time of the Battle of Midway in 1942, the Devastator had already become outdated. It was slow, lacked maneuverability, had minimal armor protection, and was almost defenseless against Japanese fighters, forced to fly low and straight in order to release its torpedoes. Devastator pilots became easy targets in the sky. The result was catastrophic losses. Most of the squadrons were shot down without achieving proportional tactical success. The Devastator stands as a stark reminder that in modern warfare, even a design only a few years behind in upgrades can quickly turn into prey. In the air, survival belongs to those who evolve fastest. With a single engine, a 3-man crew, and the sleek design typical of the late 1930s, the Fairey Battle was once expected to become the backbone of Britain's light bomber force. At the time of its introduction, it was not a poor aircraft. Compared to early 1930s standards, it was modern, featuring an enclosed cockpit and a sturdy all-metal airframe. The problem was timing. When World War II erupted, warfare had evolved at a breathtaking pace. During the Battle of France in 1940, the Fairey Battle was assigned to low-altitude daytime bombing missions, where it faced faster German fighters and dense anti-aircraft defenses. Its slow speed, limited defensive armament, and lack of adequate armor made it almost a stationary target in the sky. Heavy losses forced Britain to withdraw it from frontline service within a short period. The Fairey Battle was not useless because of a flawed design. It was tragic because it belonged to a chapter of warfare that had already closed before it had the chance to prove its worth. The Vought F-7U Cutlass was one of the boldest fighter designs of the 1950s. With its tailless delta wing configuration, high nose profile, and twin engines buried deep within the fuselage, it looked like something straight out of a science fiction film. The U.S. Navy envisioned it as the future of carrier-based airpower in the jet age. Reality, however, proved far less glamorous. The Cutlass frequently suffered from underpowered engines, making carrier takeoffs risky and unreliable. Its complex hydraulic systems were prone to failure, and its fragile landing gear led to numerous accidents directly on the flight deck. The aircraft's high accident rate earned it grim nicknames among pilots. The Cutlass was not necessarily a flawed concept, it simply arrived before engine performance and materials technology were mature enough to support its ambitious design. In military aviation history, the future sometimes arrives too early, and the cost is paid by those who are tasked with flying it. In the final phase of World War II, as Germany was collapsing under pressure on all fronts, the Heinkel He-162 was introduced as a last, wonder weapon. It was designed for rapid, low-cost production, relying on substitute materials such as wood due to severe shortages of metal. The original plan even envisioned assigning it to young, inexperienced pilots. On paper, the He-162 was an extremely fast jet fighter, capable of matching many of its contemporaries. In reality, however, it was fraught with risks. The rushed design led to structural instability. Its top-mounted engine was prone to mechanical issues, and pilot training time was dangerously insufficient. Numerous crashes occurred not because of enemy action, but because of technical and human limitations. The He-162 never had the opportunity to alter the course of the war. It became not a symbol of strength, but a stark reminder of desperation, when a nation stakes everything on a final gamble in the skies.